All right, welcome to Chapter 5 on systems of two linear equations and two variables. So this is section 5.2 on the substitution method for solving systems of equations. So the substitution method allows for the solving a system with non-whole number solutions, and it's one of two methods that allows for this. Now, the nomenclature for different types of systems. We have consistent systems and inconsistent systems. Within the consistent systems, these contain at least one solution to this system. Now, we have independent. Now, when the consistent system has one unique solution or one ordered pair, that's independent. Now, when the consistent system has more than one solution, basically infinitely many solutions to be precise, we call it the dependent. Now, inconsistent systems basically say there's no solution to the system. So we're going to kind of start, if we do it, we'll give a solution, maybe, the 2, comma 4 and say it's independent and consistent. And so we're going to add in a couple other terms for each of the items, consistent and then dependent, or consistent and dependent, or it's just inconsistent. And sometimes I'll remember to add this. Sometimes I forget. So bear with me there. All right, what is the substitution method? Well, we're going to solve one of the two equations they give us for one variable in terms of the other. So we'll solve one of them for y, and then what we can do is we do it for whatever's the easiest one to solve for here. So if it's easier to solve equation 2 for y or equation 2 for x, we do that, and that's what we want to do, find the easiest one to solve for. And then we substitute that expression for the variable into the other equation. So if we had solved, y equals 2x plus 1, then we're going to substitute 2x plus 1 into the other equation and then solve for the remaining variable, which in this case would be the x. Then once we get that solution, we substitute that into either of the original equations to find the value of the remaining variable. So we plug it in and solve for the y in this case. And we're going to get out an xy ordered pair for the solution. And as always, once we get a solution, we need to check that solution in both original equations. Now, we don't want to do it in any of them we've done any arithmetic on because we might have made a mistake somewhere. So we always want to do it in the original equations. All right, so here it says solve the system of equations using substitution and perform the check. All right, so we have two equations and they're already both solved for y. So this is pretty one of those simple equations. What we can do is we can say, okay, well, let's take this piece and we're going to plug it in here. Okay, because that's what y equals to. So we'll plug that in for y. And so get negative 2x minus 9 equals 2x minus 1. Now what do we do? Now we solve for x. So I'm going to say, well, let's add 2x to that side. Let's add 2x to that side. So those are gone. Now let's add 1 here, add 1 here. Okay, so we basically, if we want to show our cancellations, that canceled that, that canceled that. And so we did kind of two things in one step. Now we have a negative 9 plus 1, that's a negative 8. 2 plus 2 is 4x divided by 4. And so x equals a negative 2. Well, now we can plug that into either one of the original equations. Now, it looks like smaller numbers occur in this one, so I'm always kind of lazy in that sense. So let's plug it into the second one. 2 times negative 2 minus 1, and so y equals a negative 4 minus 1, and so y equals negative 5. So that tells me my solution is supposed to be negative 2, negative 5. Now, is it truly that? Well, I don't know. Let's plug it in. So y is a negative 5 equals negative 2 times negative 2 minus 9. So minus 5 equals, well, that's going to be a plus 4 minus 9. And minus 5 equals a minus 5. That's true. So it works there. What about the other one? The other one is minus 5 equals 2 times negative 2 minus 1. Minus 5 equals minus 4 minus 1, and minus 5 equals minus 5. So it works in that one. And so we know that is the solution. Now, remember, we're going to have to type in some other things here. So we have to say it's consistent and independent. So this is consistent and independent. Okay, so that's kind of the other items that they can ask for. Is it a consistent system or is it an independent system? And so those are other kind of questions you can ask. So if we plug everything in for all of our answer, then we already know what it is. But we always have to solve for it, do our check, and then after that we can determine everything else. All right, how about this one? And again, we're just solving by substitution, so I'm not going to read the directions every time. Well, we have one equation solved for y already. So what I'm going to do is I'm going to take this piece and I'm going to plug it right in there. And so that gives me a negative 3x minus 3 times. Now I have 6x minus 6, and that's equal to a negative 24. Well, now I have to simplify, so I have to distribute negative 3x, and that's going to be minus 18x, and that's going to be plus 18 equals negative 24. Well, now I've got like terms here, but I have to get rid of that 18 here. So I have 18, 19, 20, 21, so it's a negative 21x equals, and that's going to be 2, 3, 42, and it's also a negative. And so now I divide by negative 21. So x is equal to, well, that's going to be negative divided by negative is positive. 42 divided by 21 is 2. All right, so I've got my x. Now I can plug that back into the first equation and get my y. Y equals 6 times 2 minus 6. Well, that's equal to 12 minus 6, which is equal to 6. So it says I've got an answer of 2 comma 6. Okay. And before I write independent and consistent, I'm going to check it first. So I'm going to say, is 6 equal to 6 times 2 minus 6? Well, that's 12 minus 6, and 6 equals 6. So it works in the first one. How about the second one? Minus 3 times, and my x was a 2, minus 3 times my y was a 6 equals negative 24. So I have a minus 6 minus 18 equals negative 24. Well, that's a negative 24 equals negative 24. It checks there, and so it's independent and consistent. Okay, and so that is my solution. 2, 6, and it's independent, consistent. All right, so let's stop there and we'll come back with more.